Thank you again for joining us today on our webinar, which will be on scalability and performance testing with the OpenDDS Bench framework. I'm Jen and I work with the team here at Object Computing, and we're pleased to have one of our principal software engineers, Tim Simpson, here with us. And he'll be introducing Bench, a new performance testing framework that's being developed to enable large-scale testing of OpenDDS discovery and transport mechanisms. So as a reminder, we'll be doing a live Q&A session at the end, and we'll do as many question and answers for you all as possible. There is a chat over at the bottom, well, depending on your application, the bottom of the side, and we do have Adam Mitz here, the practice lead for OpenDDS as well, and he will be trying to answer questions while Tim is presenting. So if you want to pop some questions over in there, you are more than welcome to do so. But we would like for you to put them in the Q&A. That's easier just to keep track of them, and we can answer them live at the end. So with that, we are recording, and we're planning to post this on demand for viewing afterwards as well. So I think that's it for me, and I will turn it over to you, Tim.
All right. Thanks, Jen. Yeah, hello. Welcome to the OpenDDS Bench webinar. Like Jen said, my name's Tim Simpson, and I'm going to be giving a discussion today on OpenDDS Bench, what it is, what it can do, and why you might be interested in using it or contributing to it. So before we get started, just a quick look at the agenda for this webinar. So after a brief introduction, we're going to take a look at the motivation for the current iteration of Bench, the capabilities of Bench, starting with the basics, but then touching on some of the more advanced stuff later, the basic architecture of Bench today, and the basics of what's needed to configure and run Bench scenarios. We'll take a quick look at a couple demos of Bench, and we'll briefly discuss some of the output from those demos. And then we're going to take a look at where Bench might go in the future, and we'll end with some Q&A. Before that, oh, I am not sharing. I have my sharing paused. I apologize for that. So hopefully everybody can see the agenda.
Yes, we can now.
Yes.
Thanks, Tim.
Yep. Okay. Thanks for letting me know. Right. So introduction, just a little bit about me. I'm a principal software engineer at OCI, and I work primarily on the OpenDDS project. I've been doing performance-oriented C++ programming for over 15 years now, and I've done work in a number of industry settings, including defense, hyperspectral imaging, and remote sensing systems, as well as I've done a stint of time in the financial industry. I have experience with both embedded and real-time processing systems, and I generally enjoy the complexities of high-performance multi-threaded systems and systems of systems. And so I've been working at OCI for about 5 years now in various capacities, and I've been working on the OpenDDS project for, I guess, almost 4 years now. So, right, what is Bench? There's a good chance that most people using or interested in OpenDDS don't necessarily know what Bench is. I don't take that for granted, since it's unique to OpenDDS and it doesn't directly align with any of the DDS standards. Bench is just short for benchmark, and it's a tool that we use, at its core, it's a tool we use for benchmarking OpenDDS, and it's a scalability and performance testing framework that we are currently using. The current iteration of Bench is actually the second iteration of it, and we'll talk a bit more about what motivated a second version in a second. But the primary difference amounts to our needs for a tool to test OpenDDS performance and correctness at scale. So if you see things that say Bench 2, that's really what I'm talking about, but we're just calling it Bench today because it supersedes version 1. Bench currently lives inside the main OpenDDS repository, and if you've ever built OpenDDS recently with a new enough compiler, there's a good chance, if you built it with tests, there's a good chance that you've also built the Bench libraries and executables as well, maybe without even realizing it. The documentation for Bench lives in our internal docs directory, and it lives there as a restructured text file, so you can view it with GitHub, and it'll render things and include the images. And it's mostly up to date, although Bench is very much still evolving and growing. So it doesn't hurt to go look through some of the examples as well. Bench is currently in active use, both as part of our continuous integration workflows and also as part of our ongoing performance tracking activities. And we'll talk a bit more about that later when we talk about ways you might be interested in using Bench. So let's talk a little bit about what motivated the latest changes in Bench. The previous iteration of Bench had been around for a while, and you may have seen the results of its tests on the OpenDDS performance webpage. It was able to capture a number of useful statistics like sample latencies and jitter and estimated throughput. And it was also capable of capturing these for a number of OpenDDS transports and for quality of service, various quality of service settings. Unfortunately, it was also fairly tied to a few small types of test topologies, kind of idealized tests, really. And it relied on a lot of scripting to access and run test processes across predefined sets of machines, which is not all that useful, especially if your test environment goes away. It was a bit of a heavy wrapper of OpenDDS functionality. For every new configuration parameter you add to OpenDDS that you wanted to test, you also had to add support for that configuration parameter to the bench test application. And so it didn't make it very easy to support the ability to create, new parameters for testing. And it also didn't support the ability to kind of grow to arbitrary numbers for different DDS entities. We knew we would need a number of pretty significant changes in order to be able to test the sort of performance questions we were asking about how OpenDDS performs at scale and whether or not it was reliable and stable under load. And that's what motivated this new version of Bench. Right, so where have we landed? What can Bench do now? We thought it was important to cover most of the functionality of Bench version 1, which is why we're just kind of reusing the name for the sake of consistency. That way we can keep updating the performance webpage with the same sorts of graphs and output as we had before. We're capturing the same statistics. But in addition to all that, we're also able to support larger numbers of machines, including virtual machines, which can be discovered at the test runtime itself. And we support a larger number of OpenDDS configurations without the need to add new code to the test framework. In essence, we did this by wrapping less of, we have a lighter weight wrapper around OpenDDS. And so we gain access to more OpenDDS functionality by wrapping less of it. We also have better support for isolation between the test framework and the test processes themselves. And we've taken pains to not introduce performance degrading operations like memory allocations and disk IO in the statistics gathering portions of the tests. And now Bench has support for statistics on things like discovery times, which it didn't before, and also for things like per node statistics. So for example, CPU utilization for the machines that may be running the test processes. And Bench can do more than these things as well. But in order to kind of talk about how that's possible and what all it can do, it might be helpful to stop and take a look at some of the architecture of how Bench exists today. The Bench design relies on 3 primary processes for getting its work done. The first process is we just call it the worker process. This is really the workhorse of Bench. It's in charge of creating and destroying DDS test entities, and it's responsible for reading and writing the DDS test sample data. The behavior of the worker process is dictated almost entirely by an input JSON configuration file. And then workers also generate a report file based on the statistics they've gathered and the successes and failures that they've seen along the way. And that report file is written out at the end of the test. The second process, the node controller, can be thought of as a daemon for launching and managing worker processes. It accepts requests to launch workers, and it sets up temporary workspaces for them. It spawns the process, and then it manages cleanup as necessary. But it also collects the reports from the workers and the logs that might have been generated by the worker processes, and it publishes those back out into DDS for anyone who's interested. And then the third process is called the test controller, which is what most users of Bench will be running directly. And the test controller takes a JSON scenario file as input, and the scenario file just points to a number of worker configuration files and their counts. And then after listening to see if there's any node controllers available, it divides the worker configuration files among the free node controllers according to the rules in the scenario file. And then it sends off the requests to each individual node controller and kind of coordinates the test overall. The test controller then waits for the reports from each node controller, and it'll show some basic summaries of the statistics gathered, in addition to maybe storing the raw report data for further post-processing. Another design aspect of Bench is this idea of there are two DDS planes. Since all three processes use DDS for communication, it's important to make sure that there's no crosstalk between what's the test framework and what's the actual test. And so in order to isolate this, we talk about a test plane, which is the worker-to-worker test traffic. And we also talk about a control plane, which is the requests from the node controller, or from the test controller to the node controllers, and then also the reports back from the node controllers back to the test controller. Since these are completely separate, these two planes, it's worth noting that these don't even need to be using the same OpenDDS configuration for discovery or transport, or even the same version of OpenDDS. The control plane could potentially be using something like a stable version of OpenDDS with a centralized discovery mechanism like the info repo, but the test plane could then potentially be using the latest and greatest changes to RTPS in order to test the performance changes there. Currently, almost all of the use cases for Bench are using the same version of OpenDDS for all three processes, but it's definitely possible to mix and match. For those who like visuals, here's a diagram of one potential test execution environment. Here you can see there's 4 different machines, A, B, C, and D. B, C, and D are all running instances of the node controller, and each node controller has spawned 3 worker processes. The worker processes are all talking to each other on the DDS test plane, while the node controllers are all talking to the test controller running on host A via the control plane. To understand a bit more about how these processes work together, let's take a quick look at how we configure things. First, we have the worker configuration files. These are pretty large because they're dictating like all the behavior of the DDS test process. But in here, I'll show some examples in a second, but I just want to talk about the sections briefly so you'll understand what you're looking at when we look at the JSON. There's a section that'll be for test timings. So that's for enabling DDS entities, assuming they haven't been enabled at creation, starting and stopping test actions, which we'll talk about in a second, and then destruction of the DDS entities. There's a section for global parameters, or perhaps some additional timing or discovery configuration. Then there's a section which outlines all of the things that you might put into your OpenDDS configuration file today in your .ini file. And this is what one of the aspects that allows us to kind of access any of the functionality in OpenDDS without needing to have a heavy wrapper, is we include a version of the INI inside the JSON config files. And then the DDS entities themselves, how many participants, topics, publishers, subscribers, data writers, data readers get created, and what their QoS settings are, etc., are all contained in the next entry in a section in the JSON file. And then finally, you'll see a section that outlines actions, and the actions are various processes that will, for example, write new sample data, or if you're reading sample data, you could create an action that forwards what's received on to potentially to a different topic. And then we also have actions for things like setting content filtered topic parameters in case you want to try to exercise those as part of the bench test. So I'm going to have to switch my sharing here for a second, but I will open up. Let me do a new share of the. So this is hopefully you can all see this now. This is the JSON configuration file in our repo as viewed on GitHub. This is it's a worker configuration file for a simple Echo client. So as I mentioned before, you have test timing information up here at the top. If you're wondering what the negative values are, those are just relative values as opposed to absolutes. You can also put in absolute time values here. And in fact, the test controller often will substitute these timings, which are relative, for absolute timings, just to make sure that all processes are using exactly the same time. Then you see the configuration section, which is where you might have your OpenDDS INI config settings in here. These are just a few settings that have been set for this test. The debug level is off because we don't want to generate much in the way of logs. And we have a pending timeout so that we don't hang forever when data is lost. So, and then down here, we have sections that outline the creation of the various DDS entities. So for example, we have the creation of a participant. We are setting some, potentially setting some quas here. And then we are creating a few topics, a subscriber, a data reader, and then a publisher and a data writer. This echo test is bidirectional, so it has both a reader and a writer for reading back what's echoed back. And then at the very bottom, we have a test action. And in this particular example, it's writing 1,000 samples. It expects it to bounce, to hop twice. So it's got two, it will collect the round trip statistics after 2 hops. And then it's sending a payload of 100 bytes, and it is using a frequency of 100 bytes per second. So let me, I'm going to open up the second worker example here. And this is now the server side. So you'll see that this configuration is very similar. It has the same timings. It has the same configuration section. And here it is creating both a reader and a writer again, although they are subscribed to, the topics they subscribe to are different because it's the reverse of before. But here the action, instead of publishing, you'll see that the action is forwarding. So it takes the data that it reads from data reader 1 and it writes it out to data reader 2. And then let me switch back to presentation. So the next configuration file, type of configuration file you would need to know about are the scenarios. These are much shorter, but they still have some important info we'll talk about first, and then I'll show the example for the scenario for the Echo client and server we just talked about. So the scenario has a name and description. It's describing the test overall, and then it has, it can either have, or it can have both, a full node description, which is for what you might use when you need to guarantee that workers run on the same node. So this would be very important for things like, say, shared memory, where if they're not on the same node, they won't connect to each other. And it includes the counts for the different workers that you want. So you would specify perhaps, you know, like one configuration file, but you want to run 3 or 4 of them on the same machine. And then exclusivity, which is whether or not that node is allowed to be used for any other workers. So if you wanted to say this one machine only gets used for running a specific process, because you need to isolate. You need to prevent other processes from interfering with it. You could set the exclusivity flag. And then there's also a section called any nodes, and those are workers that can run on any free node that has availability that isn't marked as exclusive by another allocation. And these are probably what get used more often, especially in scale tests, because you may not have as many nodes as you have processes. But this also can include counts. And at the very end, you'll see that there's a test timeout, and that's kind of the emergency brake, as it were. So if something gets hung or crashes or whatever, you're not getting the reports back. This is the how the test controller and the node controller coordinate when to end the test, even if something is poorly behaved. And so I can take a look at the scenario, and I think I have to share the my browser again. So hopefully you can all see this. As I said, these files are much shorter. This one in particular doesn't have the full node description. It only has any node, so this can run on any available node controller. But it has a name, it has a description. It's saying, I want you to run one client and one server, and they can run on any free node controller. And there's a timeout of 120 seconds, which it should never take that long because the test itself is only running for about 10. So, minus discovery time and startup delays, etc. Right. So now that we've seen both sets of configuration files, let's see. I think next is the demo, right? So I'm going to show you two different examples of demos. One is on a local machine here at my house. So I need to share that screen. So hopefully you should all see a PuTTY window now. This is a local server at my house. I've got OpenDDS built. This is
Tim,
master.
would you mind making that a little bit bigger?
Well, let's see if I can figure out how to do that.
If it's important that we need to see it in detail. If not, then that's fine. It's just small, but if we don't need to really see it, then that's okay.
Yeah, no, I appreciate that. Let me see if I can. Is that better?
Yes, thank you.
Okay, I'll have to do that again in the other window. Okay. So as you can see, I'm in the performance tests bench directory of OpenDDS. And what I'm going to run here is the echo test we just looked at the configuration files for. So this in particular, this run test PL is how we run our continuous integration tests for OpenDDS. So this is actually one of the tests that gets run every time a pull request is created, multiple times actually for all the different builds we have. And so I'm just going to point out a few things as this runs. So the first thing you should see is that it's actually launching a node controller. So there's a node controller that's temporarily run locally so that the test controller has something to talk to. The test controller then reads in the config file. And because we've run the node controller locally, we get to see the output of the node controller. We see that it discovered one, and then it shows us that it's launched two different worker processes. One of them will be the server, and one of them will be the client. So we wait for a few seconds while it finishes up its test. And then I'll scroll up. And you see that it's telling you that it gets 2 out of 2 expected reports, and then it gives you a brief summary of some of the statistics that it found. And there's ways to save these statistics off in greater detail to be post-processed otherwise, but the test controller does give you a summary of what's of what it saw. So for example, here it saw it had 30 different samples collected for CPU utilization, and it gives you the the mean, the max, the min, standard deviation, etc. for CPU utilization, for memory utilization, for virtual memory utilization. These are percents. And then it'll also tell you things about the test timing. It'll tell you that it didn't have any, it got all of the expected discovery matching that it expected. And it tells you some information about the discovery times as well. And then down at the bottom, we have various latency, jitter, throughput statistics, as well as round trip latency, round trip jitter, round trip throughput, which the round trip may be important if your tests are running on separate machines. In this particular example, our processes are both running on the same machine, which is my server. So the clock skew is not important, but if you're worried about clock skew, the round trip statistics are helpful for making sure that you're getting accurate results. And it shows where these results are written. The next test I'm going to show you will look fairly similar, but hopefully I can point out some useful differences after I change the font size. So this is a window into a internal machine at OCI. I can't remember which font size I used, if it was 14 or 16. Okay, so hopefully everyone can see that.
Yes, thank you, Tom.
So this is an internal virtual environment at OCI. It's essentially, it's 3 40-core machines all working together to host virtual machines. And so we've divvied that up into 30 different 4-core VMs. And so you will see when I launch this that there will be 30 node controllers discovered. And we're going to run a test on it that's just for discovery. And it's going to do discovery for 60 different worker processes. And so it's not going to show you the results of all the node controller output, but it will show you the collected statistics at the end, because the node controllers are all running on different machines than the one that I'm running on. So hopefully you can all see this. You see here it's discovered all these node controllers. So there's these are the GUIDs for the participant, in addition to the names of the node controllers. And we wait a second. This test runs a little longer, I think, in order to allow discovery to happen for such a large number of processes. And then what you see is that you get 60 different reports back because there were 60 worker processes, and it gives you all the statistics that we saw before. But in particular, you see quite a few more discovery delta times reported back. The mean for this particular round was 2.7 seconds for discovery, but the max was 4.4. And so, if you were curious about why the max was that much more than the mean, we could, you could start to try to profile and set things up. We look at those things all the time. And then you'll notice also that there were no latency, jitter, throughput, because there was no user data sent. This was just a test for discovery, and that matches how we set up our scenario. So that's actually correct. And it's what it's expected. Okay. So those are the demos of kind of what it looks like to run Bench. So let me go back to the presentation. So what else can Bench do? And we've sort of, we looked at some of the typical use cases of Bench, but what else can it do? Bench supports many of the DDS APIs for the sake of profiling. So for example, it can also, read data using either listeners or weight sets if profiling those differences is important to you or important for how you've set up, your particular test application. It can do basic checks for correctness, and we use that in our CI tests, as well as in our performance tracking. It doesn't help, it's not great if OpenDDS is fast but incorrect. So we're checking that everywhere we can. It's got things like checking for the expected number of matches for discovery correctness, expected number of samples for transport correctness, and then also doing things like ordering issues. Was any data dropped? Was any data duplicated? Was any data out of order, etc. It has to know a little bit about the QoS values being used. So there is some complexity to some of those checks. It also has support, maybe this is more interesting to you for your potential use, is it has support for running processes other than just the bench worker. And so, this allows you to potentially do interesting things like general network performance of your test environment. So you could potentially use the test controller and node controller along with a tool like iPerf to, coordinate distributed tests on multiple machines to get network performance data all coordinated at the same time. Or you could potentially, be launching processes along with like a TCP dump on specific nodes to be able to capture traffic during larger scale tests. It's also very handy. Personally, I can attest to how handy it is for running things like valgrind or other analysis tools like callgrind as when you're testing as part of a larger scenario. And it also has, currently it has support for processing, some of the statistics in different, post-processing ways. And we'll take a look at one of those in just a second, where OpenDDS has a performance tracking website that it collects statistics based on all of the most recent merges to master. And so I'll show that on the next slide. The current active uses of Bench, I mentioned some of these. So OpenDDS, the continuous integration that runs on GitHub, the workflow, the pull request workflows run a lot of our tests, and Bench is included in those. We're not running the biggest, beefiest stress tests in CI, but we do run some lightweight stress tests just to make sure that we haven't, shot ourselves in the foot with our most recent changes. And then we also have a performance tracking website that allows us to make sure that we haven't negatively impacted performance versus based on the changes that have been merged into master. And so every time a merge commit is made to master, the internal test environment that I just showed you the demo for will pull down the latest version of master and run some of the larger tests like the discovery test that I ran to make sure that performance hasn't been too negatively impacted. And we have a website for viewing some of the results of those. And so I can show you real quick what that looks like. And I, of course, need to share this web page again. So hopefully you can all see this. I'll zoom in a little bit. Actually, I don't know if that's helpful because it cuts things off. So we have a few scenarios, but in particular, we had the discovery scenario, and the statistics that we're interested in was the discovery time. And so, for example, for the last 4 builds, 4 merges, you see that the test runs are captured here for the various numbers of nodes that we ran the test with. So the one that we ran was 60. And so I believe our average test time was about in line with these tests our average discovery time was about in line with these numbers. So it's a good sign that, what we can run manually matches what we're seeing when the system runs it. And you see this you can evaluate various interesting performance details, like the fact that average discovery time actually tends to go down a bit as nodes go up until about 60. 60 seems to be about the sweet spot, and then it starts to go up again. And I think that's mostly for RTPS. That's an artifact of the fact that it's using multicast, and then each multicast will generate responses. And so what you have is more traffic yields more traffic, and that's beneficial up to a point, and then eventually it actually starts to scale with it starts to increase with scale, as you might expect. And then this isn't a huge spike at the end. There's actually quite a big gap between 200 nodes and 320 nodes. And we haven't pushed it too much further than that in this test environment. Not that we couldn't, just that that's not where our focus is at the moment. But you can also do interesting things on this website, like you can, pick which commits you're interested in comparing and all these things. So this is just one example of how we're using the results from Bench, as part of our normal development environment. And some of the statistics that can be gathered from it. So let me go back to the presentation. Right. Oh, I don't think I got everything here. Right. So what else can it do? So these things are all maybe very useful for OpenDDS development, but if you're not an OpenDDS developer, why do you care about these things, right? Well, Bench also has the added benefit of you can use it to prototype, and you can use it for trying to duplicate bugs. So, or perhaps you're thinking about building a brand new OpenDDS system, and you're not sure about the performance of OpenDDS, and you're not sure if it's going to meet your needs. And so you could, using the JSON config files, map out what you thought your deployment was going to look like and try to implement, the payloads and frequencies that you thought you were going to be writing. And you could run that in your own test environment without ever having to write a line of OpenDDS application code. And then you could check the statistics, and you could see whether or not it looked like it was going to be able to keep up. Or perhaps you have an OpenDDS system, and you've spent a lot of time writing your OpenDDS applications, and things aren't working quite the way that you want, and you're not sure if it's an issue with your code or if it's an issue with OpenDDS. Well, you can try to duplicate the basics of what you're doing in your test environment with Bench, and that ought to give you some clarity as to whether or not it's an OpenDDS issue, or it's perhaps an issue in the application code that you're developing. And one of the greatest things about it is that it's open source, it's free. You can download Bench, and you can download OpenDDS, and you can run them yourselves. And so you can take OpenDDS and Bench, and you can develop all these things in your own environment, and then you could perhaps send it to someone to, if you were interested in having OCI help you take a look at the issues you're having with OpenDDS, you could send us your configuration files without ever having to share a line of code. And so this allows it to be easily portable. It runs on Windows, it runs on Linux, it runs on Mac, and just like OpenDDS does. And so it's easy to move it around and run it in different locations. So that said, we have some thoughts about how we can make it better. What else is possible? So the potential future of OpenDDS, of Bench for OpenDDS, some of the JSON configuration files can be a bit verbose, and part of that has to do with the fact that the JSON parsing is auto-generated based on the IDL from the DDS spec. And so if we improved our some of our code generation there, the JSON could get a bit cleaner. We could add support for better support for the DDS security scenarios. So right now, security works with Bench, but all of the security artifacts have to be manually generated. So to make this a little saner for scalability testing, we could add support for the test controller to automatically generate the security artifacts needed. So the certificates and governance and things like that. Those things could be created or distributed by the test controller in a cleaner fashion. We could add new statistics. There are definitely things that we think that we might add in the future. Things like dropped packets on various nodes to test for network congestion on the various nodes, and also support for different types of throughput calculation, those sorts of things. And we could also have statistics for built-in topics. So currently we're not really utilizing built-in topics as part of Bench, but we could potentially do things like, check for the performance of the built-in topics in comparison, with how discovery times and things like that. We could, add support for greater ease of certain more difficult statistics to display. So things like being able to display time series statistics a bit cleaner. That might be useful, for example, if you wanted to have graphs for looking at all the different CPU utilizations over time for all the different nodes in the system. We could, things like that could be added to some of the post-processing. And also allowing for multiple test phases, and that might be helpful for simulating topology changes. So right now, all of the DDS entities are kind of created at the start time, at the same time, and destroyed at the same time in our tests. And there's ways around that, but it might be helpful, especially for collecting statistics over the different phases if Bench had direct support for being able to kind of allow for different user-defined test phases and being able to segment statistics based on those phases. And of course, there's been interest in the possibility of using user-supplied types or user-supplied test actions for use in Bench for supplied types for testing things like the serializer and X types performance and compatibility, and then also for the actions. If there was some specialist behavior that you needed your test application to do, could Bench support calling into external code, and others. We're curious. What potential enhancements to Bench might be useful to current and potential OpenDDS users. We love to hear from you or from anyone who listens to this in the future what they think Bench could do or could do better. Before I get to the Q&A, let me just take a moment to do a brief plug for OCI. We offer training and support services around OpenDDS. We do just about anything that you need to do with OpenDDS. If you have questions, if you have support, if you want to sponsor performance improvements or feature additions, if you are interested in having us do performance and scalability analysis with Bench for a potential test environment, or if you are interested in using our test environment to test a potential system that you have in mind, we'd love to talk to you about any and all those opportunities. We also have training classes, and we have a couple training classes coming up in December. So we've got an introduction to OpenDDS programming coming up at the beginning of December, and then we've got 2 additional classes, slightly more advanced, coming up later on. The 13th and 14th, we have Essentials, where we go deeper into quality of service. And then the 15th and 16th, we have our teaching our security class for how to use DDS security. And then also worth noting is the OpenDDS Foundation, which is kind of where OpenDDS lives now. And if you're interested in becoming a member of that or sponsoring it or contributing to it in any way, the link here should help you find your way. All right, so with that, I'd like to open it up for questions and answers. And hopefully I have answers for your questions. And if I don't, then Adam certainly will. Yeah, love to hear from you.
Thank you so much, Tim. That was great. And as we wait for those questions to come in for the Q&A, Adam, did you have anything that you wanted to ask Tim?
Sure. One thing that would be maybe interesting to get into in a little more depth is, let's say that I was interested in setting up my own cluster of servers, virtual machines that would run these tests. What would I need to know to get that running in a way that would work well with Bench?
Right. So and the real the challenge that you'll face in trying to set up a cluster or even a number of machines is running the node controller. And the node controller needs to be discoverable on the network by the test controller. So, there needs to be network access there, and the node controller needs to have an OpenDDS config file that lets it talk to the test controller. So for our test environment, since they're all running Red Hat Linux, we're just using, the Linux init service to launch a script that runs the node controller. So we have as a network share in that environment, we have the built version of OpenDDS that we are interested in using. And so each machine at startup navigates to that share and launches the node controller using the config file that they all share in common with the test controller there. And that's how they get started. There's a little bit of trickery involved with our VMs in order for them to come up with the right host names. It's not required, but it is handy. So I mean, I think that maybe boils down more to DevOps and making sure that your VMs have the the DNS names that you want them to, but that's not necessarily required for running the node controller. Yeah, and one of the interesting things is that that it doesn't have to be run in like a homogeneous environment either. You could potentially, with the node controller, you could do something like say your test environment had something like 3 or 4 Windows machines and then a couple Raspberry Pis. You could potentially set up node controllers running on all of those devices, and then in your scenario file you could say these processes run on the Windows machines, these processes run on the Raspberry Pis, and then when it runs, like as long as the test controller can discover all those nodes, it knows how to allocate the different configurations to the correct node controllers. Hopefully that was helpful. So I mean, the real answer is you just need to figure out a way on your cluster to run the node controller at startup. And if that version of the node controller might change, then it needs to be in a place that's easy to access or installed on that machine in a place where it can find it.
Thanks, Tim. When you discussed the future capabilities, I think one that we may want to go into a little bit more depth on is handling the configuration. Like, what would in a future version of the system, what would you expect an end user to do in terms of creating and changing configuration?
Yeah. So just as an artifact of the way that our the parsing of the config files works right now and the way it's using auto-generated code, currently it doesn't have support for things like named constants that come from the DDS spec. So for things like the listener mask that gets passed in, those have to have numerical values associated with them, which are not particularly intuitive. And also for things like QoS, since QoS operates in a way where all QoS settings are kind of deviations from the default QoS values that are used for the parent, the factory entities. Currently the JSON uses the idea of a QoS mask, so values won't be set unless the bit on the mask is set to true, and it's a bit clunky, and so we'd love to clean that up at some point, but it also doesn't. It's it's more of a gotcha than a showstopper, because you just have to make sure that anytime you set a value for QoS, you're setting the mask value for that QoS setting to true. I see. I think Adam answered a question on the monitor. Yeah, I think we'll leave that to hopefully a separate answer.
Yeah, so we can stay on for just another few minutes here in case anyone has any other questions, but that was great, Tim. That was really interesting.